Well, Tim, we're seated here today at Rocky Hill Observatory in Sonoma, which is in a nice circle of life for the beginning of your film with the start in Florida and then sitting here today to have an interview to talk about the film. Can you give us a sense of that bridge between the early youth you had to the point that you now have this wonderful observatory here to use?
Well, if you start out with a little telescope observing the stars and you keep at it over the years as I have, it's kind of a dream to one day have an observatory where you can always go and use the telescope conveniently. So after decades of hauling telescopes around the back of vans and going up to high altitude locations and so forth, I did finally build an observatory here on Sonoma Mountain.
And could you tell us a bit about the type of telescope you have installed here?
Well, Isaac Newton, back in the 17th century, invented what we call today the Newtonian telescope. It's the kind of the simplest and most popular form, and that's what I have. It just uses a light-gathering mirror, which reflects the light back to a flat secondary mirror, which just gets the light out of the way of the light path so that you can look at it without sticking your head into the light path. It's very simple, and yet it took Isaac Newton to come up with it. So the telescope here is a Newtonian reflector mounted on an old drive that I bought used. It's about a 30-year-old drive. The telescope can be used both visually or by putting a digital camera on it photographically. And like so many telescopes today, since it's completely controlled by a computer, you can control it right there as you're standing there, or you can control it remotely. The room in which we're sitting is one floor below the telescope, and if it's freezing cold out, it's sometimes rather inviting to put a camera on, let the telescope image away, and come downstairs here and have a cup of tea.
Tim, one of the aspects of astronomy that's so fascinating is the simplicity and the accessibility. One can simply go out and lie on the beach and look at the sky and stargaze.
One of the great things about stargazing is that it's immediately at hand for so many people. You could get into scuba diving or bird watching, but the stars are always up there, even from a light polluted location. If you use a little effort and with a binocular, small telescope, there's usually something you can see, even if it's just the rings of Saturn, the moons of Jupiter.
Well, one step above lying on your back and staring upwards is to get a pair of binoculars. If I wanted to get into doing that, what type of binoculars would you recommend?
Well, a larger pair of binoculars, meaning a larger object lens, the second number in the binocular, like a 7x50 as opposed to a 6x25, will give you more light gathering power, and that's going to show you more in the night sky. So typically the best binoculars for looking at the stars are the biggest ones. The only trouble is that pretty soon they get too big to be held to hang on to comfortably. You start getting into using the tripods.
In your film, one sees many types of telescopes being utilized. Can you explain to us basically the physics of the different types of telescopes?
All the telescopes that amateur astronomers use today are either reflecting telescopes with a mirror, refracting telescopes with a lens, or the increasingly popular combination of the two, in which you have a correcting lens and a mirror and folds the optic path 2 or 3 times within the tube so that you get the equivalent of a big telescope in a small package. A lot of people make their own telescopes too. If you really want a lot of light gathering power for the lowest price, then building a big telescope in your garage is the best way to go. There's been a tremendous advance in the portability of telescopes. There are amateur astronomers now, and we saw 1 or 2 of them in the film, who have telescopes bigger than anything in the world a century and a half ago, that they can fold up ingeniously and take to a dark sky site in the back of an ordinary SUV or a station wagon.
And if I wanted to build one of my own, how hard would that be?
Well, it all depends on who you are. If you're handy, you can build a pretty nice telescope in a month or 2. People used to grind their own mirrors, and many still do, and it gives a satisfaction to make your own optics. But mirrors are pretty inexpensive, so a lot of times it's if you want to save some time, You buy a good quality mirror and just make the telescope that houses it.
So if I were picking a telescope to look at a near object and a bright object, for example, the moon, how would my choice vary from what I would pick if I wanted to look at a distant galaxy, say Andromeda?
There's a lot of difference in the nature of objects out there. A galaxy like the Andromeda galaxy describes a big piece of sky. A more distant galaxy is very small. The moon's a big object in the sky. It's a half a degree in diameter. Planets are, have a disk that looks a lot larger than a star. So there's no one telescope that's really perfect for all these objects. The question that really comes up is field of view. And I've always myself liked to have a wide field of view. It gives you a sense that you're still out there looking at the sky. And we have today a lot of telescopes that will give you a good flat and yet wide field of view, a kind of a spacewalking sense. And I find that very pleasant to see a sharp image, for instance, of Saturn or Jupiter against a starry background. Really gives you a sense of what's going on out there. A lot of telescopes you see people using today are Schmidt Cassegrains and other folded tube telescopes that are capable of giving you a pretty decent field but also supporting high magnification.
I think we understand how to plot in 3 dimensions on Earth using our XYZ axis, but how do you do it with a telescope?
Objects in the sky are located by a grid that's just like latitude and longitude here on Earth. It's really just a projection of that grid onto the sky, since the sky looks kind of like the inside of a sphere, although of course it isn't. And one set of those lines is called declination, and that's the angle going north-south from the equator toward either pole, plus declination for the north and minus for the south. And the other one's called by the rather awkward term right ascension, or RA, and it's counted in hours, 24 hours around the globe. So if you know the right ascension and the declination of an object in the sky, you know exactly where to point the telescope.
Several times you refer to averting your eye off center in order to improve your observing power. Could you explain to us why that's the case?
If you look directly at an object through a telescope, you won't see it to the best advantage. The way the eye is constructed, it does not see dim things best at the center, but a little bit off. It's a hard discipline to master, but you need to look just a little away from the object you want to see, and you will instantly see that it comes out much more vividly. This is typically true with galaxies and nebulae. There's a planetary nebula called the blinking planetary because it demonstrates this so clearly. When you look at it, you don't see much. As soon as you look sideways, it comes out as this glowing ball. And of course, the tendency of the brain, as soon as something appears like that, is to look right back at it, at which point it'll dim down again. So it takes a little getting used to.
There's a wonderful scene in the movie where a young boy finds a book with star chart, then you show him outside looking at the heaven and learning the stars basically from that book.
That's right. There's a tremendous amount you can do without any optics at all. I'm still learning the night sky. I was learning a bit of a constellation last night, just in a few minutes outside looking up, because I realized that Virgo, which is the constellation right next to Leo, a rather dim constellation, I had kind of lost sense of the structure of Virgo. I'd kind of forgotten how it hooks up, so I was trying to remember that. So there's always something you can learn and enjoy in the night sky. You can enjoy stargazing just going out and learning a couple of constellations with your kids. In a sense, what happens as you get more involved in astronomy is that you're probing further into space. It's sort of as if you started out just swimming and snorkeling, and then you got interested, so you start scuba diving. And there's literally no limit to how far you can take that. It is a genuinely infinite subject in which there is no limit to how much one can learn.